Download this code from codegive.com, link in the description below. Tutorial: Good API Design for Effective Rate Limiting. Introduction. Rate limiting is a crucial aspect of API design, ensuring that a service can handle varying loads without being overwhelmed. A well-designed API can facilitate better rate limiting strategies, leading to improved performance and user experience. This tutorial covers best practices for API design that aids in effective rate limiting, along with code examples. Key concepts of rate limiting. Rate limit: the maximum number of requests a user can make to an API in a specified time frame. Burst limit: the maximum number of requests a user can make in a short burst, often exceeding the rate limit for short periods. Throttling: temporarily limiting access after the rate limit is exceeded. Quota: a limit on the total amount of resources a user can consume over a longer period. Best practices for API design related to rate limiting. 1. Use consistent rate limiting strategies. Choose a clear and consistent strategy for rate limiting, such as fixed window, sliding window, or token bucket. 2. Identify resource consumption. Determine which actions consume the most resources. Prioritize rate limits based on resource consumption. 3. Provide clear documentation. Clearly document your API's rate limits, including how they are calculated, when they reset, and the responses users can expect when limits are exceeded. 4. Implement client identification. Use API keys, OAuth tokens, or IP addresses to identify clients for rate limiting. 5. Differentiate between user and application limits. Set different limits for users and applications, allowing for more flexibility. 6. Graceful degradation. Design your API to handle overload gracefully, providing informative error messages and potential workarounds. 7. Use HTTP headers for rate limit information. Include rate limit status in HTTP response headers to inform clients of their current limits. Code example: implementing rate limiting in a simple REST API. In this example, we'll implement a simple REST API using Python's Flask framework with a basic token bucket rate limiting approach. Python. From Flask import Flask, request, JSON IFA, G. From time import time. App equals Flask, __ name __. Example rate limit settings. Rate _limit _per second equals 5 requests per second. Rate _limit window equals 60 in seconds. A dictionary to store the request timestamps for each client. Client _requests equals def rate _limit. Client _ID equals request.remote _address using IP address as client identifier. Current _time equals time. Initialize the client's request timestamps list. If client _ID not in client _requests. Client _requests client _ID equals. Remove timestamps older than the defined window. Client _requests client _ID equals T for T in client _requests client _ID if T current _time, rate _limit window. Check if the current request exceeds the rate limit. If len, client _requests client _ID, equals rate _limit per second. Return false rate limit exceeded. Add the current request timestamp. Client _requests client _ID append, current _time. Return true allowed. At approot, /API/resource, methods equals get. Def get _resource. If not rate _limit. Return JSON IFA. Error, rate limit exceeded. Try again later. 429 HTTP 429 Too many requests. Return JSON IFA. Data, here is your requested resource. If underscore underscore name underscore underscore equals equals underscore underscore main underscore underscore app run, debug equals true. Explanation of the code example. 1. Rate limit configuration. We set a constant for requests per second, rate underscore limit underscore per underscore second, and a time window, rate underscore limit underscore window. 2. Tracking requests. We use a dictionary client underscore requests to store request timestamps for each client IP address. 3. Rate limiting logic. The rate underscore limit function checks the number of requests made by the client in the last rate underscore limit underscore window seconds. If the count exceeds the limit, it returns false. 4. API endpoint. The /API/resource endpoint checks if the client is within the rate limit. If not, it returns a 429 status code with an appropriate message. 5. Running the application. The application runs on Flask's built-in server for demonstration purposes. Conclusion. Good API design plays a vital role in effective rate limiting. By following best practices and implementing a robust rate limiting mechanism, you can ensure your API remains performant and user-friendly, even under heavy load. This tutorial serves as a starting point for creating APIs with effective rate limiting strategies.